Dyno run sounds pretty good, doesn't it? You know why it sounds so good? Because you got 2,000 CFM of carburation. And why does that make it sound better? Here's why. Where those blades are open and it's got all that air exposed, you can actually hear the sound coming up through and out through the carburation. So you can actually hear the actual valve train. It sounds way better with 2,000 CFM. But anyway, let's get started on the video. Hey guys, this is Eric Weingardner with Weingardner Racing. Today's video is tunnel rams. I actually dyno tested this one against some single planes and some dual planes on the dyno mule. Those results will be shared in this video today. I'm finally gonna get to bust some of the myths that people keep spreading about these tunnel rams. But I've got 3 up here just to kind of show you some of the differences. And the only one that really got tested was this one. So I'm just showing you these just for reference. So the different designs. There's 2 others that I wish I had here in the shop that I would love to show you. One would be the Holley Pro Dominator, which is a tunnel ram. And then also the M&M has a tunnel ram, and that's a new design. That thing's amazing. I've showed it in previous videos. You can go back and watch that one. That one's a good one. It really, really is. And I would love to test that one on the dyno mule. I'm gonna try to hit them up. Maybe they'll send me one. I just can't throw out the coin for that. But yeah, that tunnel ram is amazing. But this is the one that got dyno tested, and we're going to talk all about it. But let's just go through some of them just before we get to the actual results and stuff. This one is an Edelbrock street tunnel ram. You can still purchase this today from Summit, Jegs, doesn't matter. It's available. And the good news about it is it comes exactly like it says here. So when you order it, you get both pieces, the base and then also the top. This one's probably been around forever. Yeah, long time. Really popular piece, and it's the smallest one. This is exactly how it was dyno tested. I didn't alter it in whatever way. So someone else has done something just because I could tell those bolts are different from the factory. The factory ones are little 12-point bolts, and then they're smaller. You can tell the gaskets are laying through here, and there's steps through here. All that's exactly how it was dyno tested. I do plan to do some porting on this to see what changes on how that would change the power from the dyno test. But yeah, that's exactly how it looks, and that's exactly how it was dyno tested. Really popular one, probably one of the more common ones you'll see. This one's its next brother up. It's bigger brother. This is the Victor Ram. Now, if you notice, it's got bungs that are drilled here because this customer sent me this in. But this one was on a Hillborn mechanical alcohol injection deal, or Indoley, sorry. So that's what it was for. But if you look at it, its design is much different than this. So this is the street one. You could tell it's got quite a bit smaller openings than this Victor Ram. This Victor Ram is pretty big. You can tell by the openings and whatnot. The other thing with this is also still available. You can order it today. I think it's part number 7070. The problem with this one is these are sold in 2 pieces. So you've got this bottom piece, but then you have to buy the top piece. So this is all together as one, and that one you have to buy in 2 pieces. And the reason why is because I think they have 2 different tops. They've got a 4150 top, so 2 4150 carburetors, or they can run 2 dominators if you chose to do that. The other thing is, for instance, this guy, he didn't even have the top because he's running an Indoley injection, so it's got its own different top that actually bolts onto here with this butterflies and whatnot. And by the way, he sent this in to see how it would test if you float it with the Indoley injector, Indoley butterfly hat on there to see what would happen. And that's what I'm planning to do at some point on a later video because, as you guys know, if you're new to my channel, I dyno test a lot of stuff and I flow a lot of different stuff on my flow bench. So I got a Superflow 750, SF750 in it, my Signs Digital 680. I flow a lot of cylinder heads, do a lot of stuff with that. I also do a lot of dyno testing. But I am going to test is if I bolt this on to, say, a 23-degree head like this, and I flow it through the injector, so I got my butterfly up here, how will that affect the flow when it comes down here? So in other words, the air is going to have to come in this way and that way. And we're going to see how it affects. I plan to do it, see how each one flows with the injector hat on, because I have a feeling, and the guy pointed it out too, it's going to be dramatically different. Chances are this hole here is probably going to be the worst one, and these back ones are going to be better for flow-wise, because if you think of the front one, you got your butterfly here, is going to come and... Anyway, that's the reason why this one's even here. This one is no longer available, but it's also an Edelbrock piece. This is an Edelbrock Pro Ram 2, and this was supposed to be the amazing one. This was a 1-piece. So this guy had sent me in for me to port, and I don't know why, because I can port it, but I cannot weld the top. I cannot mill either. So I'm not a welder. So this was a whole 1-piece deal. So unlike the other 2s where you had 2 different pieces for the tops, this was a 1-piece deal. and this was a much older design, but several claimed this to be amazing. You kind of have to cut off the top to do the port work, but from what I've heard, these were supposed to be the best ones ever. And if you look at them, they actually have a much longer runner than the Victor Ram, and about the same length as the Street Ram. So essentially, you could take advantage of the longer runner with that one and the size of this one to make this one. This one is no longer available. You probably still could find it. It's probably expensive. But again, you'd have to cut this off, port, and then weld this on, which can be done. The only problem is for me, after you weld this on, it's going to warp the flanges inevitably. So it has to be surfaced. And I do not have a way to put on my fixture to mill stuff, to put this on to mill the sides when it's like this. If it's a single 4, I could do it, but not like this. So anyway, I know that sounds strange. The other disadvantage of this one is, and the reason why we couldn't even use it is, this one doesn't have a lot of material at the top compared to the other two. So for instance, this one for sure can go 1207 tall. This one can, I think as well, go that way. It's 1206 is pretty easy. So yeah, there's some differences in that. But I'm only showing you these 3 because they just happen to be here. The one that got dyno tested, again, was this one. So what did it go on? Well, the dyno mule that it's been going on forever is a 406 small block Chevy. It's got scat rotating assembly. It's a Dart SHP block. It's half filled with concrete because I got it as a engine that had been blown up, so they put a sleeve in it and got it repaired. But anyway, 4155 bore. It's got flat top Race Tech pistons in it, and it yields about 11.2 compression ratio. The heads that were used were stock ProMax Project X 215cc heads, and I had done no work to those. The camshaft came from Urson, and it's a solid roller, 260 duration on intake, 270 on exhaust, 108 lobe separation. And the induction part besides this is a pair of 1,000 CFM 4150 carburetors, because I'm busting some myths on that too. So the reason for the 1,000 CFM, if you watched my channel, you can go back and watch some of the dyno videos. From the very beginning, I had a Race Steam 1,000 CFM carburetor that had been redone by Mark Whitener. And that thing has just been amazing. It's beat almost every carburetor I've ever tested on the dyno. And it just has a nice, consistent fuel curve, works great. So what had happened was we tested some single planes, tested that one. I actually bought another 1,000 CFM Race Steam carburetor, so I have a matching set. Sent it off to Mark. He put the exact same thing into it. Oddly enough, same jets, same orifices, everything. Put it on the single plane before we done this test. The regular carburetor been using forever. Dyno tested it, took it off, put the other one on that was supposed to be its match sets. Put it on the same single plane intake manifold. The fuel curve was pretty close, like within 0.2 of an AFR, which is not that far off. However, for whatever reason, it was slightly up on horsepower. I want to say like 3 horsepower and maybe 1 or 2 foot-pounds of torque, but really close. It was just, I would have thought that'd be the exact same, but it wasn't. But anyway, that was that. We only just did that just to make sure the fuel curve was the same or close to the same on both carburetors, which it was. So at that point, took off the single plane and popped this dude on. And here's what changed, because I know some of you, we're going to go through a whole bunch of myths. Myth 1, you can't use 1,000 CFM carburetors. That's 2,000 CFM of carburetors on a 406 that only turn 6,800 RPM. You won't do it down low. It won't work right down low. I've heard that over and over. False. We loaded it at 3,800 RPM. No problems. Myth number 2, you're going to spend forever on jetting with the tunnel ram. Nope. 1. So all we did first off was take the carburetors that had already been on that one, plopped them on here. Didn't change anything inside the carburetor, so some of you can already tell there might be some issue, because there should be. Put them on there and made our first dyno pull. It popped right off, worked great. So in the first dyno pull, pulled it down to 3,800 RPM, 2,000 CFM, doesn't give a shit. It just pulls right through it all the way to 7,000 RPMs. But what it is it's rich. And the reason why it's rich is because that one carburetor had enough idle mixture in it as far as fuel-wise to support the entire engine. So now I have 2 that does the same. I didn't touch any of the idle stuff. Same with the jetting. The jetting was enough for 1, not for 2. So first pull, way rich. And I shouldn't say way rich, it was in the 11. So it went from, we were right at 13.0, went to 11. So pretty rich. One thing I did, so I was like, you know what? It's got to take, we're just going to take jets out. I'm not going to mess with idle bleeds. I don't even have to, or air bleeds, sorry. Don't even have to. I'm, at this point, pulled off the bowls and took 4 jet sizes out all the way around. And honestly, I probably should have pulled out another 2, maybe another 1. And the reason why I didn't is because when I took off this carburetor, it was on this one, my one I've been using forever. When I pulled out this bowl screw, the helicoils that was in the carburetor came out with it, which I didn't even know had helicoils in it. You might say, were you to over-tighten them? Nope. So what happened is changed all 4 jets and put another helicoil in and prayed for goodness that it wouldn't leak, and it didn't. So 4 jets out of all, so 4 removed from every single one. That yielded us, lucky guess, almost the exact same AFR as what it had on the single one, which was like 12, 8, 13. And that's where it was. And that's where it made its most power. By the way, and I'll show you in a minute, but with the rich side, it made 595 horsepower and 550 or 540 foot-pounds of torque. It gains 25 horsepower taking the 4 jet sizes out. But I'm going to show you those graphs here in just a second. Before I show you the dyno results, I want to show you things the other intakes I'm going to compare it to. So you're about to see the dyno results with this tunnel ram, obviously. But this is the other one I want to compare it to. This is an AFR dual plane intake manifold. And full disclosure, they did send me this to test for free. And I used this thing, and it's really, really good. And I know some of you are like, why didn't you use an air gap, an Edelbrock Performer RPM air gap? I used the actually Edelbrock Performer, and I think the air gap is pretty much the same design, except for it has the air gap. But I'll go ahead and tell you this. This AFR one was like 20 foot-pounds better of torque than the RPM at lower RPMs. Now at peak, it lost by like 3, but at the lower RPMs, it definitely made more torque, which is a very good comparison to test against that, because we're really looking to see not only is it making more peak horsepower, peak torque, but how's it doing at the lower RPMs. The other intake to manifold I'm going to compare it to is this one. This, you're like, what in the world? This is an Edelbrock 2892 that I imported for a customer, and it's actually for sale. But this guy, he wanted me to, much bigger cubic inch engine, but he wanted me to convert it to a Dominator flange, and of course I heavily ported it. And just to give you an idea why there's so much welding, all this was welded in here, which it looks like it's not. It was, and then milled off, then extra welding added on, because I kept making it change and different. So all this was welded. The bolt holes got moved. That's why there's a little spot here where I missed. All this, and as you can tell, the thing's, it's big. It's big. And I'm going to go ahead and tell you right now, this has been the best performing manifold so far. It's made more power than any of the others, even that one, which we'll get to in just a second. And this is on 2 different sets of heads now. This thing has been really, really, really good. But this is the best peak power, but it had a Dominator on it, 1050 Dominator with a 2-inch tapered 4-hole spacer on it. So that's the other one we're going to compare it to. So all 3 of these, let's compare it to this Edelbrock Street Ram. So here we go. Here's the Edelbrock Street Ram, tunnel ram. And just to give you an idea of the numbers, we'll just start at 4,000 RPM. It's making 501 foot-pounds of torque. And if you look at the peak torque, 561 foot-pounds of torque. None of the other intakes make near this torque. They don't make 561. None of them. None of the ones I just showed you, they just don't. Peak power came in at 620 horsepower, and that happened at 6,200. And then look, it starts dropping off, which we'll talk to a little bit more in a second. This is the AFR dual plane. So same engine. All I did was switch intakes. If we look at the 4,000 number, we have 494 foot-pounds of torque versus 501, which that means that this tunnel ram is still 6 foot-pounds better on torque at the very start of the run. If we look at them through the middle, this thing only made 548. This thing's still, you know, quite a bit up from that 561 to 548, quite a bit. And then if you look at peak power, remember at 6,200, this was, you know, 620. The dual plane at 6,200 was 596. So it's still way more, way more horsepower, and it also had more torque everywhere. So for all those who are like, oh, the dual plane's the king, it's going to make more torque and stuff and drive spit, this is better. It's more torque, more horsepower. But how does it compare to this big boy baddie? This is that Edelbrock 2892. Look at 4,000, 457 foot-pounds of torque compared to 500. Not even in the same ballpark. If we look at peak torque, it made 550 to 560. So it's down 10, almost 11. Peak power, though, 626, you know, versus the, I say 620. Yeah, 620. So it's up 6 horsepower there. But I actually have the overlay to give a better idea on this one. So let's look at this. This is what it looks like graphically. Yeah, the red line being the tunnel ram, the black line being the big boy manifold. You can see how much more torque it has at the low, even through the middle. It's not until 6,200 RPM that that big manifold starts really shining and just pulling away. Yeah, it's a huge difference. So yeah, that tunnel ram, even though albeit small, it's keeping up with that until 6,200. And in all fairness, the reason why it didn't beat it any higher is because it's not ported. Once I open this up and get a little bit more area there, it's all over. It's going to beat this thing. And this thing's heavily modified and all. This doing some port work on this, it's going to beat it everywhere, even at the top. And as good as this man, and this is a good tunnel ram, if I had the M&M one here, it would have beat this and completely destroyed this. It's a much better design. So this is a good manifold. Tunnel ram, it's better than this one and anything else besides this. That's the only manifold that beats it on peak power from the initial test, from those tests. This is the only one. None of the rest did. Not the Victor Jr., none. This. So it's a pretty dramatic difference. Now I should point something out because I can already hear the comments in my head. Well, it doesn't mean it's going to drive great on the street. I can tell you this, with 2,000 CFM worth of carburation on there, it's much harder to get that to load on a dyno than it is to drive in a car. And you're like, nuh-uh. You need to be on a dyno and understand it. A dyno will take an engine that's going 4,000 RPM and you tell it, all right, start the test. It will drag it to whatever RPM you tell it. So taking it at 3,800 RPM, wide open throttle, shove it all the way, drag it all the way down to 3,800 RPM. It's much harder for a fuel curve to get consistent on that type of deal versus a car. Because on a car, it's, even let's say my truck, I put it on the trans brake, it's gonna hold it there at the RPM, but the minute I let off, it's gonna accelerate much faster than the dyno will. So it's actually harder if, for a carbureted tune-up to load on a dyno than it is in a car. A car, you can get away with some of the stuff because of the acceleration rate. You can accelerate out of it. If you got issues with carburation and stuff where your turning curve isn't right, it's for sure going to show up on a dyno and start shooting ducks. It's going to pop and bang. It's not going to be happy as one to surge. It's much harder drivability-wise on a dyno than it is in an actual car. So this had no problems, which means in a car, it would have had even less. If you've got your carburation set up correctly, tunnel rams are the way to go. And I'm like, whatever. You don't know what you're talking about. Look, I tested it. And before I ever started doing any of the dyno testing, I only went by what people said too and what I might have learned or read and whatnot. Until you actually test stuff, it changes everything. So it's a myth. These things work great. Great. The only disadvantage, and this is a true disadvantage, there's no doubt about this one, the height. Because they're so tall, I mean, what are you going to do? You put the tunnel ram on here, I'm going to have it, even with my cowl induction, you'd be above that. And then some cars, you're going to look over the carburation so you can see what this tree is so you can launch. That's the really only disadvantage, is it's just so tall. It's just a disadvantage. Or though you could be like the LS guys with their high rams and just take their hood off and leave it sticking out. When that high ram came out, I actually thought, there's no way these are going to sell. People don't want to take off their hood. They don't even want to use like a 4-inch cowl for these tall single planes. No, they just took off the hoods. How many LSs do you know, like in Camaros and Corvettes and stuff, and even Mustangs, that they're like, no, we just don't want a hood. We'll run that high ram. It cracks me up. I never thought they'd do that. But anyway, back to the point. These are good. These are really good. So if you're a tunnel ram fan like I am, they do work. And there will be future testing done with this, I promise. So currently, I just finished on Thursday the 6th round of dyno test. All of this took place in dyno session number 5, which means if you would like to purchase any of this data dyno, so you have a hard time seeing it on a little screen, but you wish you had a book in front of you could see, you go to my website, wengines.com, and you actually can order the book. I'm not really gonna close it, but all the orders that are pre-ordered so far for Dyno Session 5, which have this and many other tests in it, I'm going to, at the end of today, whatever there is that's pre-ordered, I'm gonna do that and 10 more copies, and that's it. And once they're sold out, you can only get them on a PDF, which I'll sell that. But if you wanna see that, any of that, that's fine. You can see that too. You could also sign up to be a channel member, which would really be great, because when you sign up for those, you actually, as the tests are going on, which happened last Thursday again for people, they got texted the actual dyno results, and I asked them, hey, dude, is there something you want to see while I'm on the dyno? I got a few seconds. And I can test some of that too, which happens as well. So you can sign up to be a channel member. You can also get these books so you can see this stuff easier. And it just, if you're into data, it's a huge thing. It's not opinion, it's all data. So they look like this, in case you're wondering. Drop stuff out of the way first. This is the big block Chevy one, just happened to be one I could grab, but they all just look like this. Dyno numbers, and then there's graphs. And sometimes at the beginning of the books, like they'll have the measurements for the heads, if those heads were tested. The flow numbers for the heads are usually in here too. I mean, it's just everything, see flow numbers for heads. So if you're into just data, purchase the books. But anyway, that's what's going on. Hope you guys got something on the video. Remember, I'm no Superman, and I do appreciate all of you for watching. I'm just trying to bust some myths, and tunnel rams are great. You guys, remember, I'm no Superman. You guys take care.